I want to switch to a camera.
Camera.
Okay, and bring it closer. All right. Well, well, what do I have here? This is so-called pressure bulb. Well, this looks like a bulb, and this scale measures pressure. And what if I place this bulb in, let's say, ice water? I have here some ice. If we wait a little bit longer, we can see that the pressure starts decreasing. Okay, we can see the pressure changes. Fine. The question is, what does not change? Well, technically, when metal cools down, it shrinks a little bit. So little bit that we can neglect that change. So we can assume that the volume, total volume of the system remains constant. But also, of course, we don't see any holes. We don't add any extra molecules in it. So the number of moles also remains constant. What changes? Well, temperature because of the ice, and pressure. Very conclusive, that's why I'm gonna try to do the opposite. Hot water. Okay. You can see clearer how now, because water heating up the gas inside due to heat exchange, the temperature of the gas inside this bulb increases, and that results in higher pressure. And the lab number 8 allows to establish the relationship between temperature change and pressure change. The name for this process is isochoric. Iso in Greek means constant, choric means volume. So this is isochoric process, the process which happening with a constant volume and amount of gas. All right, let's use this again. So if I squeeze it, we can see the piston moving. Of course, because I do the work. I do the work on the gas, and the gas does the work on this piston. But what if, instead of doing work, I'm going to just place this plastic bottle in hot water. Oh, what's happening? Why does it move? Actually, very, very slowly. But still. Well, now we need to use our knowledge of mechanics. For every location of this piston, the force from the gas is balanced by the gravity. But the force of gravity only depends on the mass, so it remains constant. That means for every location of this plunger or piston, the force from a gas acting on it also remains constant. Force over area is pressure. So this is the process with constant pressure. What's going to happen if I now place it in ice? See, Why? Why? Well, because now, in order to provide the same pressure to compensate the same gravity, gas should use a different amount of volume. Do we change the amount of gas? Do we change how many moles? No. I could if I would open it, but I don't do that. So again, the number of moles is constant. The pressure is balanced, constant due to the constant mass and area. What changes? Temperature and volume. And again, we can do some experiments to figure out how temperature and volume are related when pressure remains constant. I need more hot water in the future. And there's one more standard isoprocess. So this process has a name isobaric or isobaric. Yeah. Iso, constant bar pressure. Constant pressure. And one more, which I'm gonna show using camera, document camera. Let's see if I have it here. I have here small pieces of paper. Inside it, and I can put a plunger in it, and this it's not gonna work. Okay, let's close this door. Now I'm gonna put some in this. The plunger should be very tight, and one rubber ring broke. Okay, so paper, plunger, I move it very slowly, nothing is happening. Now what I'm gonna do? Did you see it? I put this paper on fire. Why? I did the work so quickly that all my energy from my hand transferred into the internal energy of the paper. So the temperature of the paper, well, the gas in the paper jumped very quickly, so high that the temperature has become enough to put it on flame. And here I've got the opposite situation. I have a CO2 cartridge, and if I poke a hole in it, gas will expand, loses energy, and the work done on the gas is negative. Temperature should drop really quickly. Let's see if that's going to happen. See? Well, why is it important? Because